So I am recording. Feel free to stop me, though. I could always pause and re-record. This is the final section of Chapter 8, Solving Rational Inequalities. So hopefully you guys already jotted down these steps. Step 1 is to solve it as if it were an equation. You could pretend that that's an equal sign and just solve it, right? So let's actually do that first. Let's pretend it's an equal sign and solve it. So how would we solve this? By getting rid of fractions. Which fraction would you like to get rid of first? Doesn't matter. Pick one. The one with the 5x. We're going to multiply everything by 5x. Multiply everything by 5x. Multiply everything by 5x. Now, that's great because that will eliminate with that, and you no longer have a fraction. Now it's just a regular 4. You have the plus sign. And over here, if you think about the 5 and the 10, that actually does reduce. 5 over 10, if you reduce by 5, it'll become a 2 on the bottom and no more 5 up on top. So we really have plus a fraction that's a 1x, or just an x, over 2. And you have the less than symbol that comes down. And likewise over here, the 5 does not cancel with the 2, but the x does cancel with the x. So that guy and that guy cancel out, and we end up with a 15 over 2. So now, obviously, let's cancel out those other fractions by multiplying everything by 2. This times 2, this times 2, that times 2. So 2 times 4 is 8, plus, that guy cancels out, x, that comes down, this cancels out, 15. What do you think so far? Pretty easy, right? Okay, so now let's get x by itself. By the way, we could pretend that this is an equal sign. You don't even have to, you could just leave it as an equal sign if you want. So what we have here is x is, let's just put an equal sign, 7. I guess you could technically leave it as a less than. But anyway, I'll put both. X is less than 7. That's the technical actual answer. But you could pretend it's an equation and leave it as x equals 7. Step 2 is to set your denominators equal to 0 and solve. Now, the reason why we would do this is because if you have 5x, and if you set that equal to 0, that whole thing becomes undefined. So we're technically finding the value that would mess it up so we could avoid it. Because on an inequality, you have an area of answers, right? And we'll get to that in a bit once we get through the steps. So anyways, we're going to take the 5x and we're going to set it equal to 0. So set 5x equal to 0 and solve. So that's really 5 times x equals 0. Divide by 5, divide by 5. X equals 0 divided by anything is still 0. Okay, so when you take the 5x and you set it equal to 0 and solve, you get x equals 0. That is a value that you want to avoid because the x value of 0 would cause this inequality to become undefined. Same thing over here. If you were to set 2x equal to 0 and solve it, you're going to also get the same answer, x equals 0. So step 2 was to set your denominators equal to 0. 5x equals 0, 2x equals 0. Solve both. In this case, both of them gave you the answer 0. Step 3, plot all answers on a number line and test the areas. So we need to go to a number line, plot our answers right there. We have the answer 0 and the answer 7. Okay, so we have 0 and 7, and we need to test answers. Okay, so I'm going to test the area that's on this side of 0. Okay, so give me a number that's on this side. Something easy would be like -1 or -2, right? What do I use? Pick one. -2. Okay, so I'm going to test -2 and see if it works. And I want to try to show you on the calculator how you would do this. So the idea when you are plugging in -2, you're supposed to plug in 4 over 5 times -2 plus 1/10. And then and over here, plug in the -2 down here and see if it's a true statement. So I'm going to type in on the calculator the input of -2. So again, we are typing in the -2 that you guys told me to type in. 4 over 5 times -2 right there, plus 1/10. You do that, hit equal, and then it'll give you an answer, -3/10. But that answer, you could hit the SD button and it'll change it to a decimal. So technically on this left side, you have -0.3. So you have -0.3, and then you have the inequality, less than, bless you. And on the right side, when you type it in, If you type in a negative 2 right there, it'll be 3 over 2 times negative 2, that's negative 4. So negative 3/4, which would be a negative 0.75. So the question is negative 0.3 less than negative 0.75? No, it's not, right? You owing 75 cents is a lot worse than owing 30 cents, right? It's more negative, it's further on the left side, it's not greater, okay? So this is false. So what does that tell you about this answer right here? That it doesn't work. So it doesn't work, right? So now we're going to test another number, like maybe the number 1, which is clearly between 0 and 7. Okay, so if we try the number 1, I'm not going to use a calculator because it's pretty simple. Plug in a 1 right there, that gives you a 4/5. 4/5 plus 1/10 equals 3 over 2 times 1, that's 3 over 2, okay? If you want, you could use a calculator and do 4/5 plus 1/10, or you could just change this to a 10 by multiplying by 2, that'd be 8/10 plus 1/10, that is 9/10. So if you wanted to, you could have typed it into the calculator, 4/5 plus 1/10, it'll give you 9/10. Oh yeah, and it's not equal, it's a less than symbol, I apologize. So is 9/10 less than 3/2? And of course, you could change that 2 to a 10 by multiplying by 5. That would change to 15 because you multiply it by 5. So is 9 less than 15? Yes, it is. And of course, you could do all this on the calculator. So this would be a yes. And test another value, like let's say 8. Try 8 over here on the right side of 7. Okay. And it's not going to work. Let me just show you on the calculator. So when I type in the 8 into the x, I get 4 over 40, which is technically 1/10 plus another 1/10. This was easier to do without the calculator, actually. And you get 2/10, which is 0.2. So you have 0.2 on the left side is less than, and if you type in an 8 right here, you'd have 3 over 16. So on the calculator, if you go 3 divided by 16 and then change it to a decimal, you get a 0.1875. So if you do this on the calculator, the left side gave you a 0.2, and you have the less than symbol, and on the right side, if you do it on the calculator, it's 0.1875. So is 0.2 less than 0.1875? No, it's not. 20 cents is not less than 18 cents. So this last section obviously is a no. No, that doesn't work. So what area works just between here and here? Just like that. So that would be a compound inequality, 0 on the left side, 7 on the right side, x in the middle with less than symbols. So this would be your answer to this question. And by the way, this is a question number 11 on your worksheet, by the way. Step 1 is to solve it as if it were an equation on this question. So we're going to get rid of fractions. We're going to get rid of the 3 first, multiplying by 3, multiplying by 3, multiplying by 3. No more fraction, you got x minus, but you still have a fraction here. 1 times 3 is 3, that ends up being a 3 up on top, and it's still over x minus 2 on the bottom. And it's a less than symbol. Over here, the 3 does not cancel with the 4, so technically I need to distribute the 3 with that binomial. 3 times x, 3x, 3 times 1, positive 3, and it's still over 4. We might as well now get rid of this second fraction, the binomial x minus 2, okay? So if you do multiply by the binomial x minus 2, it'll cancel that second fraction. But you have to multiply everything by x minus 2. That means this by x minus 2, and also this guy by x minus 2. And that's where it gets super fun, because you have a binomial that you have to multiply by a binomial. So you have to distribute and combine like terms. Anyway, right here, when you distribute, x times x is x squared. X times negative 2 is negative 2x. And then, of course, this fraction canceled out, so you have a minus 3 left over. You still have the inequality, which you could call an equal sign if you wanted to, right? You know what? I'll do that, because we're going to be testing areas anyway. I'm just going to put that as an equal sign. And then over here, you're going to distribute 3x times x is 3x squared. 3x times negative 2 is negative 6x. Positive 3 times x is a positive 3x, and positive 3 times negative 2 is a negative 6. And if you combine the middle terms, you'll get a negative 3x in the middle. So what we really have is the 3x squared, the negative 3x in the middle, and the minus 6 at the end, and it's still all over 4. So we're going to put it all over 4. So we got rid of one fraction at a time. We've gotten rid of 2. We still need to get rid of that last one. That last one's pretty easy. Multiply everything by 4. That'll cancel it out. Multiply by 4, multiply by 4, multiply by 4. So the x squared is going to now become a 4x squared. The negative 2x times 4 is now going to become a negative 8x. And the 3 times 4 now becomes 12. And it is equal to that fraction, 3x squared minus 3x minus 6. So we now have a quadratic equation. And whenever you see the power of 2, you might as well move everything to one side to set it equal to 0, because maybe you'll be able to factor, split, and solve. That's what we're doing here. We're going to move the 3x squared over by subtracting it. It'll cancel out. Subtract 3x squared. You will get a single x squared. Okay? I'm going to do all 3 steps at the same time. So I'm going to then move the minus 3x by doing a plus 3x. That'll cancel it out. And what you do to one side, do to the other, plus 3x. You get a minus 5x. And last but not least, let's move this minus 6 by adding 6. What I do to one side, do to the other. Negative 12 plus 6 is negative 6. Put that in black. Equals, we canceled out everything on the right side, it equals 0. Why did I do that? Because now that I have a quadratic trinomial that's set equal to 0, I might be able to factor it. Put an x there and an x there. And you think what times what is a c value negative 6 that if you add together is a b value negative 5? Anybody? Negative 6 and 1. Okay, negative 6 and positive 1. Thank you very much. All right, so then you could split it and solve, right? So if you have something times something equals 0, that first something, x minus 6, that could equal 0. And also the second something, x plus 1, that could also equal 0. So when you solve both of those, you're going to get 2 answers. X equals positive 6 and x equals negative 1. Maybe. You got to double check and make sure that the 6 doesn't cause that to become 0. It doesn't. That negative 1 doesn't cause it to become 0 either. Therefore, those are your answers. But you still need to move on to step 2. Step 2 is to take your denominators and set them equal to 0 and solve. And those are going to be other answers that we're going to post on a number line. Okay. So the only denominator that could be set equal to 0 is that x minus 2. So if I take that x minus 2 and set it equal to 0, we get the answer x equals positive 2. So we have these 3 values that we need to put on a number line. Okay. So you have 3 values that you want to put on a number line. You have the negative 1, you have the 2, and you have the 6. So we need to test areas. So like let's say you wanted to test the left side of negative 1. So you might want to plug in, like let's say negative 2. Okay. Now what does that mean? That you're going to plug in the negative 2 right there. It'll be a negative 2/3. Plug in a negative 2 right there. Plug in a negative 2 right there. And see if it really is this side being less than this side. Okay. So with the calculator, you could plug in that negative 2. And you'll get negative 5/12. And of course, you could hit the SD button and it'll change it to negative 0.416. So I'm just going to write negative 0.416 right there. And that's on the left side. Now, if I plug in my negative 2 right here, negative 2 plus 1 is negative 1 over 4. That's negative 1/4. That's negative 0.25. And it is a less than symbol, so it's less than negative 0.25. Is that a true statement or false statement? Anybody? Is negative 0.4 smaller, more negative than negative 0.2? Yes, so that's a true statement. So that means that our answer so far is the inequality x is less than negative 1. Now, we still need to test the other values. So we're going to test, let's say, test 0. That's between the negative 1 and the 2. So we're going to test the actual value 0. So you're going to plug in a 0 up here and down here and up there and see if it really is that the left side is less than the right side. And if you test it with 0, you could just plug in 0 with the calculator. Wait, that's not 0. testing 0 with the calculator. And that'll give you the answer 1/2, which is a 0.5. Okay, so I'm going to write that down. 0.5 is less than, and when you test it on the right side, plug in a 0 right there. That'll be a 1/4, which is a 0.25. So is that a true statement? Is 0.5 less than 0.25? That is false. 50 cents is not less than 25 cents. 50 cents is greater than 25 cents. So this would not be included in your answer. Then you got to test another value, like testing 3 or 4, right? I want to test the value 4, see if that works. Why did I pick 4? Because I already have it typed up right here with the calculator. When you type in 4 over 3 minus 1 over 4 minus 2, that gives you 5/6, which is a decimal 0.83. So on the left side, when we type in the 4, you get a 0.83. So we're going to put a 0.83. Is it less than? Why less than? Because there's a less than there. And then type in the 4 right here. 4 plus 1 is 5. 5 over 4 is 5/4. And that's 1.2 as an answer. So if I put the 1.2 on this side, is that a true statement? Is 0.83 less than 1.2? The answer is yes. So that means that my answer is also in between the 2 and the 6. So that's going to be technically a compound inequality. And if you were to test another value, like let's say a value out here like 8, you're going to see that it doesn't work. I already typed in the 8 with the calculator. When you type in an 8 right there, on the left side you get a 5/2, which is 2.5. 5/2 is 2.5. And it's supposed to be less than the right side. And if you type in an 8 on the right side, 8 plus 1 is 9. 9 divided by 4, I have it written right here on the calculator. 9 divided by 4 is 2.25. So is 2.5 less than 2.25? No, it's not. 2.5 is greater than 2.25. 2.5 is not less than 2.25. So that's a no. So that means that this guy doesn't work. So what are our answers? We have different inequalities. This first inequality, you would write it as x is less than -1. That's one answer. Then you have the word or, because it could also be the area between 2 and 6. So that'd be a compound inequality. 2 on the left side, 6 on the right side, x in the middle, less than symbols. So that would be your complete answer. X is less than -1, or 2 is less than x is less than 6. Yes. Okay. I'm done. Yes.